back to my channel. In today's physics calculation series 2, we shall be answering some of the high physics questions you must take note of as you are preparing for any of your forthcoming physics exam. So without wasting time, we'll be getting started now. So let's read the first question together. It reads, a rectangular block of length 10 meter with breadth 8 meter and thickness of 4 meter has a mass of 550 kg. Now what's the question? Calculate the density of the block. We are asked to find what? Density. So let's see how we solve this solution. Okay. First thing first, we are going to be deriving all the parameters I was given in this question. So it reads a rectangular block of length 10 meter. We have length in this question. That is small l. They said is what? 10 meter. What else? They said with breadth of 8 meter. So breadth in this question, small b, is 8 meter. Now they now said and thickness of 4 meter. Okay, you can write small t or you can also use h. They are the same thing. Okay, h or t refers to the same thing. Where h is what? Height, and thickness and height are talking about the same thing basically. So we progress. They said has a mass of 550 kg. So m in this question was given to be 550 kg. So we move on. What is the question? Calculate the density of the block. Now density is symbolized by this type of P, okay? And then in this question, we don't know what our density is. Our P is unknown. So let's solve. We know that density, okay, on a norm, density is mass over volume. We have the mass from this question. But were we giving the volume directly? No, we were not giving volume directly. Instead, we're giving the length of the block, we're giving the breadth of the block, and also the height. Now, what formula do you think we can use to get our volume before we can now find our density? That formula is what? V equals length times breadth times height from normal mathematics. Okay? Volume of solid shape. We can use this formula to get our volume first before we continue. Now, what was given to be the L? L was given to be 10, whereas breadth was given to be 8, and lastly, height was given to be 4. So these are all that we have. So moving on from here, let's see what we get. V will now be equals to what? 10 times 8 is 80. 80 times 4 will now give us, that's about 320. Okay? And now what will be the unit for volume? Volume will be in what? Meter cube, because we're giving meter as the unit. So 3 of it will be meter cube. Okay, so this is now our volume. So guys, now we know the mass to be 550 kg, and now we have succeeded in finding our volume to be 320 meter cube. Can we now come back and find our density? Yes. So let's fall back to this. We said density is mass over volume. Okay, from here we will now have, we have our value for m and v. Let's now find density. Density will now be equals to, in place of m, what do we have? 550, okay, over, in place of v, what do we get? 320. So we are going to be dividing 550 by 320 to get our density. And now density will now be equals to, let's see what that will give us, okay? Let's see what that will give us. 550 divided by 320. That gives us approximately 1.72. Okay? This is if you are approximating to the second dp. You have 1.72. And do we stop here? No. There should be a unit for density. What is the unit for density? Density, the unit for density is kilogram per meter cube. And this will be the answer to this very question. So you can go through it again and make sure you understand how it was being solved. So without wasting time, guys, let's get to number 2. Okay? Solution. Let's read the question and see what we are asked to solve here. The question read for this. If it takes 5 hours to drain a container of 540 meter cube of water, what is the flow rate of water from the container in kg per second? So this is what we are asked to find. We are asked to find flow rate in kilogram per second. We are asked to find the flow rate what? Kilogram per second. Kilogram is the unit for mass. Second is the unit for what? Time. So we'll be dividing the mass by what? The time. That's basically what we'll do. Whatever we get, we'll just add that unit to it. So let's get started. Derive what I was given in this question. They said if it takes 5 hours. So we're giving time in this question. Our time was given to be 5 hours. But we know that in physics, hour is not the standard unit for time, is it not? So what is the standard unit of time we have to convert this to? The standard unit for time is what? Second. So guys, we are going to be converting from 5 hours to what? Second. And to do that, you multiply by 60 twice. Why are you multiplying by 60 twice? The first 60 we have to convert hour to minutes. While the next 60 we now have to convert from minutes to what? Seconds. So you have to multiply by 60 twice if you are converting from hour to second. So I can add my x here for second. So if I do this multiplication, let's see what we'll get. 5 times 60 times 60. That gives us 18,000 seconds. Okay? So this is now the time we'll be using. This is the value of time we'll be working with and not 5 hours. Okay? So let's progress. If it takes 5 hours to drain a container of 540 meter cube of water, 540 meter cube. Meter cube is a value for what? Volume. It's a unit for volume, I mean. So the value that go with it will be for our V. Is it not? Our V in this question is 540 meter cube. That is our volume. So the question here is, what is the flow rate of water from the container? So assuming they were pouring the water away and we know all these parameters, what will be the flow rate in kg per second? So we can say our flow rate is unknown. Our flow rate in this question is unknown. But guess what? They have actually helped us out. They said we should find flow rate in terms of kg per second. And kg per second simply means give us an idea that we are going to be dividing the mass by time. So without even knowing the formula for flow rate, I can come here and say flow rate is equals to mass over time. Okay? Because that was the unit they asked us to find flow rate in. So we know that kg is for mass, second is for time. So I've succeeded in finding the formula for flow rate, which I need to solve this question. So now what do I do with this formula? I can now continue and say flow rate is now equals to, now first thing first, do we have our mass given directly? Was our mass given directly in this question? No, mass was not given directly in this question. Is it not? Now we don't know the mass. We know that if mass is not given, we have to find the mass for which we go to find flow rate. Now look at this very well. We have volume. Okay? And we know that density of water is a constant. It has a constant value of what? 1000 kg per meter cube. So I can recall that density, if density is equals to, okay, mass over volume, making mass subject of this equation by cross multiplying, mass will now be equals to what? Density times volume. So in place of this mass, I can say density times volume over what? Time. Now, that's why it's good. Perhaps in most questions, they would have given you the density of water directly, okay? But if it wasn't given, know that the density of water is exactly 1000 kg per meter cube, okay? Now, I have succeeded in substituting P times V for mass because they are equivalent based on what we got from here. Now, what is our volume as given? Our volume is what? 540 in meter cube. And what was our time? Are we going to say 5 hours? No. Instead, we use the equivalent, which is what? 18,000 seconds. So I'll come here and write 18,000. So we are still continuing it. Flow rate. So from here, what will now happen? Flow rate will now be equals to, let's do this with our calculator and get our answer. 1000 times 540 gives us 540,000. Now we are dividing that with 18,000. That gives us 30. 30, exactly 30. And what do you need to say we should find our answer in? stated in kg per second. So I'll come here and add kilogram per second. And this is the answer to this very question. So you are free to go through it and ensure you understand how this question was solved. So about now, we'll be getting to question 3. Alright, here is question 3. It reads, an object is projected with a velocity of 80 meters per second at an angle of 30 degrees to the horizontal. Now, the maximum height reached is, so in this question, we are asked to find maximum height. And there was something I underlined here, so I can use it to explain. Now, we are seeing projected at an angle. That brings our mind back to what? Projectile motion. This question was from projectile motion. And mind you, if the angle was said to be given at an angle to the vertical, you don't use it. But because you're giving straight to the horizontal, we can use it directly. So if you are going to ask me, what if the angle was given to the vertical, what do I use? If they are said at 30 degrees to the vertical, the value you will work with is actually going to be 90 minus 30 degrees. If it was 45 to the vertical, the value we work with is 90 minus 45 degrees. If it was 60 degrees to the vertical, the value we work with will be what? 90 minus 60. But because it was given directly to the horizontal, we work with the value like that. That's something I want to explain before we get started. Now let's get started. We'll read the question, we'll derive what I was given. They said an object is projected with a velocity of 80 meters per second. Now in projectile motion, this velocity is our u, initial velocity. And they said it's what? 80 meters per second. They said at an angle of 30 degrees to the horizontal. That would be our theta. And because it was to the horizontal, we will use it directly. We'll say 30 degrees. And what did I say? If they have said 30 degrees to the vertical, what should I have written here? 90 minus 30, then that will now give us 60. Is that 60 I will now work with? Or it was to the horizontal. Then what is the question? The maximum height reached is, so maximum height, which is capital H in this question, is unknown. That is what we are going to be finding. Now basically, from our knowledge of projectile motion, the formula for maximum height is what? Big H is equals to u squared sine squared theta, okay, over 2g. This is the formula for maximum height. So what do? We will impute all that we have into this formula. Big H will now be equals to, what was our value for u? What was our value for u? They said 80. So we'll say 80. But they said we should square the 80. So I'll say raised to power 2. Then times, connecting these two with times, sine squared theta. Now this is the best way to do this thing. We will take the sine of the angle, then we will now square it. How do I write that? Sine 30, because the theta here is 30, bracket raised to power 2. So this is this. Then everything should be over what? 2 times. Now if you are given the value of g, you use it. But if you are not given, know for a surety that the value of g is approximately what? 10. So this is what we are going to be working with. So from here, h will now be equals to, now let's see 80 squared. Let's see what that will give us. 80 squared gave us 6,400. We'll come here and write 6,400 times. Now this is how we do it. We'll take the sine of the angle. Whatever we get, we'll now finally square it. So what is sine 30? What is sine 30? That is 0.5. So let's square 0.5. That gives us 0.25. Now everything over 2 times 10 gives us 20. So from here, what will happen? H will now be equals to, let's do this together. 6,400 times 0.25 gives us 16,000. Okay? 10 1600, I mean 1600, and we are going to be dividing that by 20, and that gives us exactly 80. So our maximum height in this question is 80. But do we stop here? No, we have to add a unit. What is the unit for maximum height? Height, basically, the unit is meter. So our answer is 80 meter. You are free to go through it and see how this question was solved. So straight to question 4. Solution. We'll be taking the solution immediately. So let's read the question. Two bodies, P and Q, are projected on the same horizontal plane with the same initial speed. So let's start and should I say deriving order I was given in this question. We have P and we have Q. Is it not? Now what did they say? They said they were projected on the same horizontal plane, okay, with the same initial speed. That is U for P is the same as U for Q. They have the same initial speed. They now said, but at different angle. That is, theta for P is different from that of theta of Q. So to show that these two theta are different, I will add theta subscript P, theta subscript Q. They are different. But this one, they are the same thing. Is it not? Good. So there is even no need for me to be adding subscript P and subscript Q, because the U of this is the same as the U of this. Now what else? They said, and 60 degree, that of 30 degree and 60 degree, but at different angles of 30 degree and 60 degree. So why this is equals to 30 degree, this is equals to what? 60 degree. Are we still together? Then what is the question? To the horizontal. Mind you, they said to the horizontal. So we are working with 30 and 60 directly. Then what is the question? Neglecting hair resistance, what is the ratio of the range? Okay, the question was of the range of P to that of Q. That was the question. Now we are asked to find the ratio of the range of P to the range of Q. Arrow subscript P to that of arrow subscript Q. Now we know for a shorty that range is given as what? U squared sine 2 theta over G. Range is given as U squared sine 2 theta everything over G. Now this is the formula we'll be using to solve our question. Now watch out. Since we are doing a comparative analysis here, we are comparing the range of P to that of Q. How do we do that? We have to draw a relationship here. Now, assuming G is constant, okay, we can say arrow is directly proportional to this. So since it's direct proportionality that is connecting these two guys, we will say arrow P over arrow Q. Is it not? Now, since the relationship between arrow and this is direct proportionality, I can say it's equals to UP squared times sine of theta P, then we put the square here, okay? Better still. Because putting the square here, no, there's not even no square, there's no square. Let's do this properly, there's no square. It was 2 theta P. Okay, this is what we have. This is not on maximum height. Now this is what we have for the up. Everything over. Now we are going to that of P and Q. We'll say U subscript Q squared times sine 2 theta Q. Then we cover the bracket. Now why is it like this? We know gravity will cancel. Gravity is always constant. So we are working with what is not constant. Now from here, what we have? What are we going to have? Arrow P, okay, arrow P over arrow Q will now be equals to, but we said that the U subscript P and U subscript Q are the same. They have the same value. And if that is true, we can say this will cancel this, because it was from the question. They said with the same initial speed. So we have cancelled that out. Now let's start fixing values. What will be left for the up? Sine times, what is theta p? Theta p is what? 30. So it will be 2 times 30. And 2 times 30, let me just write it out here. 2 times 30, okay, over sine 2 from here times theta q. Theta q is what? 60. So I will say 60 here. Now watch what will happen. Arrow p over arrow q, okay, will now be equals to, let's see what sine, what do we get here? 2 times 30 is what? 60. Let's see what sine 60 will be. Sine 60 is approximately 0.866 over 2 times 60 is 120. Let's see what the sine of 120 is. The sine of 120 will give us approximately 0.866. Now, if you do the ratio of this here 1, this here 1. So this is equals to what? 1:1. And this is the answer. Now, let me explain something here. This is for, let's say you are writing your UTME or your post-UTME exam. There are shortcuts to some of these topics we calculate when we are calculating. There are shortcuts. Now, for projectile motion and this type of question, when you notice that the two angles given for the two different bodies add up to 90 degrees. Now, just know that the range for the two bodies will be the same. And if the range is the same, the ratio of the range of one to the other will be 1:1. Whenever the angle add up to 90, that is to say, the angles are complementary. That's how we see it in maths. Whenever the angle add up to 90 or are complementary, the ratio of the range that will be covered by one body to that covered by the other body will be 1:1. That is to say, they will have the same range. I hope that is clear for this very question. You are free to go through it again. So about now, we'll be getting to question number 5. Alright, here is question 5. It reads, the resultant of two forces. So we're given two forces, 12 Newton and 5 Newton is 13 Newton. What is the angle between the two forces? So this is the question we are asked to solve. We'll say solution. Now, first thing first, let's derive all that was given. The resultant of two forces, 12 Newton and 5 Newton. So we call this first one F1, okay, because it was two forces. So that will be our F1. They said is 12 Newton. Then the next, they said 5 Newton. That will be F2, 5 Newton. And they said that the resultant force of these guys is, they said 13 Newton. So we can come here and write F. You can even use arrow. It's the same thing. F here stands for net force or resultant force. They said is what? 13 Newton. Now the question here is, what is the angle between these two forces that has this resultant? Now the angle theta in this question is unknown. Theta is unknown in this question. We have F1 as 12 Newton, F2 as 5 Newton, F3 as what? 13 Newton, and theta is unknown. Now how do we answer this question? There's only one formula we can use here. Okay, based on the question, we have the resultant, we have two forces, and then angle is unknown. That will bring to our mind the formula which is gotten from cosine rule, which is arrow equals a squared plus b squared minus 2ab cos theta. We can actually use this formula, but this time around we will be modifying the formula. In place of arrow, arrow stands for resultant. So in place of arrow, we can say big F, that is net force squared, okay? Net force squared is equals to F1 squared plus F2 squared plus, no not plus, but minus 2 F1, then what? F2 cos theta. This is the form we'll now be using, and this is the form that applies in physics. Now what else? Now we have this, we'll be substituting the values of each into this, and then we'll look for our theta. In place of net force, we have 13. So we'll say 13 squared, mind you, you're going to be squaring each of them, equals to f1 squared. f1 is 12, so 12 raised to power 2 plus, what is f2? f2 is 5, so raised to power what? 2 minus, watch out, 2 times f1 times f2 cos theta. How do I do that? I will say 2 times, what is f1? f1 is 12 times, what is f2? f2 is what? 5. So we can put this in brackets. Then to it, we are going to times it with what? The cos of theta. We are going to be timesing our final answer with cos theta. We have a value of for theta. Theta is the unknown. So in place of that, I will just leave it as theta. Now from here, what will happen? Let's see what will happen. 13 squared is what? That's 13 times 13. It gives us 169. 169 is equals to 12 squared is what? 12 times 12. And that gives us 144. Then what is? Plus 5 squared. The square of 5 is 25. Then minus 2 times 12 times 5. 2 times 12 times 5. That gives us 120 times cos theta. 120 cos theta. That is what we now have. That is what we now have. So we progress from here. 169 is equals to this added to this. That's what we have. 144 plus 25 is also 169. So we write 169 minus 120 cos theta. Are you seeing that? So what will now happen from here? We carry the one without cos theta to one side and the one with cos theta to another side. So this is what I will be doing. All this, I will be moving them here. Okay, the one with cos theta. Minus 120 cos theta, when it crosses the equality sign and come this way, it will become positive 120 cos theta. Good. Positive 120 cos theta. Then what do you have here left? You have 169. Is it not? Now the 169 that is here, we have to leave. I'm going to miss its pair on this side. So when this 169 crosses this equality sign and come this way, it will become negative 169. Are you seeing that? So what will now happen from here? Let's see. 120 cos theta will now be equals to 169 minus 169 give us 0. Exactly 0. Now we are looking for theta. So what do? You have 120 in front of cos theta. Divide both sides by that 120 over 120 over 120. What will be left on this side? Cos theta will be left on this side. So the cos of theta will now be equals to, now 0 divided by 120 will give us 0. Okay, you can check that out. 0 divided by 120 will give us 0. But did they ask us to find cos theta? No. They asked us to find theta, that is the angle between the two forces. So how do you now get theta? From here, how do you get theta? We have cos theta equals 0. So now make theta stand on its own. Theta will now be equals to the cosine inverse of, what do you have here? 0. Cosine inverse of 0. If it was sin theta, theta will now be equals to sine inverse of 0. That is any number that is here. If it was tan theta equals 0, theta would have been equals to tan inverse of 0. So whatever the whatever it is that is in front, that will be determine what you will take the inverse of. But in this place, it's cos inverse of 0. Now let's get that now. Shift cos, that gives us cos inverse. Cos inverse of 0 is exactly equals to 90. Now because theta is a form of angle, we'll say 90 degree. So guys, in essence, we are saying based from our calculation, we have gotten that the angle between F1 and F2 is what? 90 degree. And that is the answer to the question. So go through it and ensure you understand how it was solved. So straight to question 6, we start. Solution. Now we read, then we solve. They said a long train travels 10 kilometers northward, 4 kilometers eastward, and 6 kilometers southward and also 4 kilometers westward. Calculate the displacement. Now, before we get started, what is displacement? Now, displacement is distance covered or traveled in a specific direction. Okay? Now, in essence, the one we are going to begin to solve, you can also say displacement is the distance between the initial point and the final point, or you say initial position and the final position. Mind you, displacement is different from distance. Distance is the sum of the total, let's say, length that was covered, but displacement is what distance covered in a specific direction. So I can move like this. The distance I covered might not necessarily be equal to the displacement I covered. Okay? We will see that from this. Let me just show you an example. Imagine a boy who moves like this, moves like this. Let's say here was 3 meters, here was 4 meters. The total distance that boy has covered, okay, the total distance the boy has covered is 3 plus 4. 3 plus 4, and that is 7 meters. For the displacement this boy, or wherever it is, has covered, let's see how we will get that. Now, I said displacement is the distance covered in a specific direction. Or you say the distance between the initial point and the final point. What is the line joining these 2 points, initial and final? Is it not this? So whatever is the length of this, that is the displacement. And if you actually do the calculation of this, you have 3 squared plus 4 squared, that is 9 plus 16, that is 25. Root of 25 give you what? 5. So the displacement is actually 5 meters, but whereas the distance is what? 7. So take note, displacement and distance are different physical quantities entirely. Now we move on. Let's solve the question. I hope this brief exposition help you in your physics. Just have to bring it out before we get started. Now let's get started properly. They said a long train travels 10 kilometers northward. Now I'll be drawing diagram to illustrate. Assuming this is the start point, this is the initial position. Okay? They said it travels 10 kilometers northward. Now understand something first. This direction is the north direction. This direction downward is the south direction. This direction is the eastward direction. And this direction is the southward direction. Westward direction. So north, east, south, east, then west. I will put it on the board here. North, east, south, then westward direction. So take note of that. So we need this to solve. Assuming this is the start point, they said a long train travels 10 kilometers northward, to the north. So from here, assuming you move from this start point, assuming you move northward, this is it, and the distance they said it covered was what? 10 kilometers. Now what else? They now said it was now at this point, is it not? So this is also another point that will determine the next motion. They now said 4 kilometers eastward. From this place, it then moved where? To the east. For how long? For 4 kilometers. It moved for 4 kilometers. Mind you, when you are drawing your diagram, try and be a little bit accurate. This is longer than this. So it's now at this point. Then I said, then 6 kilometers southward. Which direction is southward? Is it not down? So it then moved downward. Then this way was, let's say here, it will say 6. Now from here, then I say, and 4 kilometers westward. Where is westward direction? Is it not in this place? So from here, it now move westward for how long? 4 kilometers. Now mind you, the 4 here and the 4 here are going to be the same. So the length of this is going to be the same length for this. So it's now finally at this point. And here it was 4. So finally, where did it end? Is it not here? It ends here. It started originally from here. And after all the movement around, it now ends here. So when they now said calculate the displacement. Displacement in this case, we will now say displacement is equals to, what do we say displacement is equals to? Final position minus the what? Initial position. That is what we are going to use to get our displacement. Now watch. Why are we doing that? Because it's on a straight line. Where is the final position? Is it not here? Minus the initial position. Now we know that this whole length is what? 10. There's a why I am using it like this. If the whole length is 10 and from here to here is 6. To get the distance between these two, we can say 10 minus 6. You know, these places are parallel sides. So if from here to here is 6, from here to here is also what? 6. So we are removing 6 from here to here from 10 to get the leftover. And that gives us what? 4. And the unit was what? They were saying kilometer. So our displacement is 4 kilometer. Now mind you, questions on displacement, sometimes you have to add the what? The direction the body is now moving. That's why displacement is different from distance. Distance is just the total length or the total position covered, while displacement is the distance covered in a specific direction. So check. Originally the guy was there. Finally the guy was here. So this remaining 4 kilometer, in what direction is he moving? Is it not upward? From the original position to the final position, the guy is moving what? Upward. Upward is what direction? North direction. So come here and write 4 kilometer northward. 4 kilometer northward. And this is the displacement. So after the moving around, the guy end up successfully covering a displacement of just 4 kilometer in the north direction. So take a look at how all these questions were solved. About now, guys, should be getting down to question 7. So here is question 7. Without wasting time, let's read it. A block of mass 2 kg resting on a smooth horizontal plane is acted upon simultaneously by 2 equal forces of magnitude 10 Newton. Now, inclined at right angle to each other. Calculate the acceleration produced by the forces on the block. Now, funny how this question may seem long, but what they actually ask us to find is a very short question. If you're actually looking at it from the perspective, another perspective, it's very short. So let's see how we actually are going to solve this question. First thing first, because of the nature of the question, we'll be drawing some diagram. Let's see what we have here. It said a block of mass 2 kg resting on a smooth horizontal plane. So we draw the plane and we draw the block. They said the block is of mass 2 kg, so our mass is 2 kg. Now what else? They said resting on a smooth horizontal plane is acted upon simultaneously by 2 equal forces. So of magnitude what? 10 Newton inclined at right angle to each other. So while one is acting like this, upward, let me draw it a bit more upward. While one is acting upward, the other one is acting this way. And the angle between these two forces is 90 degrees. So right angle. So the force here is 10 Newton. The force here is what? 10 Newton. So you have 10 Newton. Now the body is of mass what? 2 kg. Then I said that's what from here to here just finished saying. Like I said, in another perspective, if it was given as a diagram, which I'm drawing now, it's very short. But it was just some long stuff. So people easily get should I say bored. Now let's see. Calculate the acceleration produced by the forces on the block. Now we know that these two forces act at different angle. So for we to get acceleration, we need the net force. We know the mass. We can say F equals ma. But are we going to use this F as our F or this as our F? Are we going to say 10 or this 10? Now you are wrong if you pick any of these forces. The best thing to do, because there are two forces acting in different directions, the first thing to do is to get the net force. The net force, this is the direction it acts in. Because this is a right angle between these two forces, F1 and F2, the net force will act in this direction. It will act in this direction, okay? The value of the net force, which is big F, is what we now use to get our acceleration. How do we get the resultant of the net force? The formula to use will be F squared equals to, what is our F1? 10 squared. What is our F2? 10. Then you say raised to power 2. So this is what we use. Why? Because the angle between the two forces is a right angle. And the rule that applies to right angle triangle is what? Pythagoras rule. So that's why we are using this. So from here, what will we have? F squared will be equals to, the square of 10 is 100, added to the square of 10, which is also what? 100. Are you seeing that? So finally, F squared will now be equals to what? F squared will be equals to 200. 200. Now, are we to stop here? No. We are trying to get a value for F. But we have F raised to the power 2 equals 200. How do we remove the square sign? Now, to remove the square sign from this F, you take the square root of both sides. If it was square root that was over the F, to remove that square root, you will square both sides. So I'm trying to say that the opposite of square is what? Square root. So because we have square here, we will square root both sides. So we'll say square root of this side, then square root of this side. So we know, that square we cancel square roots. What will be left here? Just F equals the root of what? 200. Now what will now happen? If you do that with your calculator, the root of 200, that's approximately 14.14. Okay? Now force is a form, force is in Newton. So we add Newton. This is equal to 2 dp, 14.14. Or did they say we should calculate the net force? No. He said we should calculate the acceleration that is produced by the forces on the block. Now we know our net force. The net force is a type of summated force. Okay? These two forces and these two forces. The resultant of the two forces is actually 14.14. So it's this resultant force that we will now use to get our acceleration. So now we know our F, net force. We now say that, but we know that force is equals to mass times acceleration. Okay? So now we are now here. The F here will be our net force, which is what? 14.14 equals to our mass, which is what? 2 kg, then times A, which is unknown. And that is what we are finding. How do we now get A? We make A subject. How do we do that? Divide both sides by what is attached to A. So we are dividing both sides by 2 over 2. So we cancel 2 here. What will be left here? A will be equals to 14.14, okay, divided by what? 2. A finally will be equals to, that's what we have, 14.14 divided by 2. That gives us 7.07. Now what is the unit for acceleration? Meter per second square. And this is the answer to this very question. So you are free to go through it and ensure you understand how it was solved. So straight to question 8. Solution. The question reads, a man walks 8 kilometer north. Now as we are reading, we are illustrating. So assuming this is the start point. They said he walked 8 kilometer north. Now he's going to move northward now. Northward direction is not upward. So you will draw a line like this, and then you will call it 8 kilometer. There is now at this point. Then what other movement did he now make? Then I said, and then 5 kilometer in a direction 60 degrees east of north. Now this we have to understand what it means before we can solve this question. From here, which direction is now 60 degrees east of north? Which direction is 60 degrees east of north? Is it here? 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 I don't know. So how do we now get the direction it moved when they said 60 degrees east of north? Now at this very point, draw the 4 cardinal points because it moved to this point. So let's from here see how we get to the next direction. The 4 cardinal points here is north, here is east, here is west, and here is south. degree eastward of north. Now, if somebody moved 60 degree east of north, it means that the person was starting from north and was trying to move towards the east by an angle of what? 60 degree. So let me interpret for you. 60 degree east of north. 60 degree east of north means he started from north. He tried to move to east by 60 degree. You are starting from north, okay? You are starting from north. You try to move towards the east by an angle. The angle between this direction. This is your trying to move towards the east. By what? 60 degree. You try to move towards the east by what? 60 degree. So it is this direction the bro or whoever it is actually moved in. This is the direction he moved in. Are you seeing that? You started from north. You are trying to get to east, but you only covered 60 degree of the angle. So when you now stop, is now the direction that it makes this 5 kilometer movement. Are you seeing that? That will now be the direction it made the what? 5 kilometer movement. So we don't need this again. We don't need this. So what do we now have? We now have something like this. Watch out. We now have something like this. Is it not? Now watch out. They told us that here is 60 degree. Okay? Now we are trying to get something. The angle between these two movements, 5 kilometer and 8 kilometer. That's what we're trying to get. The angle between these two movements, from here to here and here, what is the angle in between? Now, how do we get that? From here, we know that this is a right angle. Why I drew it? This and this is a right angle. A right angle, the angle between a right angle, is what? 60. So if from here to here is 90, I mean, the angle between the right angle is 90. So if from here to here is 60, it means that the remainder will be what? 90 minus 60, and that's what? 30 degree. So now we know that the leftover is 30 degree. Okay? The one that is inside this movement is 30 degree. But there's still another angle here, that is 90 degree also, because this is also showing right angle. So you now have inside, you have 30 degree, and also inside you have 90 degree. So 30 degree added to 90 degree will now give us the final angle that is between these two guys. And what is that? The angle is what? 120 degree. Are you seeing that? 120 degree. So now the angle between these two guys is 120 degree. Now how do we now get the magnitude of its displacement? Now I have to find the what? The distance between the initial and the very final point he has moved in. So we connect them by this line. We connect them by this line. Now the length of this is what is now going to be the magnitude of what? The displacement. So this is 120 degree. Now how do we now get this? How do we now get our displacement? Let's call it x. How do we now get our resultant displacement? Now, this will bring one thing to our mind. If you've studied cosine rule, that is what we'll be using here. We have an angle, we have two known sides, and one side is not known. So we'll be using cosine rule here. And cosine rule is simply, let's say, let me use letters first. Cosine rule is c squared equals to a squared plus b squared minus 2ab cos theta. Cos, cosine rule. Are you seeing that? Now, because we don't have that CAB here, we'll be using what we have here. The C here is for the longest side. So where is the longest side? Is it this side, or this side? The answer is what? This side. So we'll call here our x. We'll say raised to power 2. Now, this other side will be our A. Okay? 8 raised to power 2. And then this other side will be our 5. Is it not? 5 raised to power 2 minus, watch out, 2 times A times B. This is our A, this is our B. So we say 8 times 5. 2 times 8 times 5. 2 times A is 8, then times 5, then cos, mind you, the angle that is between these two sides is now what? 120. So we are saying cos 120. Cos 120. Are you seeing that? Now from here, what are we going to have? X squared will now be equals to, we will now have 8 squared plus 5 squared. 8 squared is 64. 64 plus 5 squared will give us what? Now let's see that. We say 64 plus 25, which is the square of 5, minus, now we do these ones, I will do these ones. 2 times 8 times 5. 2 times 8 times 5 gives us 80. 80 sine 120. 80 sine 120. So I can come here and write 80 times, what is the sine of 120? The cos of 120, I mean. Cos 120. Cos 120. 80 cos 120. The answer I got is negative 0.5. Negative 0.5. So from here I will say x squared is equals to, because I'm trying to manage space, I will just continue this way. 64 plus, what do you call it? 25. 64 plus 25 is 89. So you have 89 minus in bracket. Now this times this, that's what we have. 80 times negative 0.5 give us negative 40. So inside this bracket we have negative 40. And there's a minus here. So how do you now work it out from here? 89 minus 40. Therefore, we have to get a resultant sign here. We have two minus. So what do? Minus times minus will give you what? Plus. So we cannot say x squared is equals to 89 plus 40. Are you seeing that? 89 plus 40 will now give us what? X squared equals to 89 plus 40. That gives us 129. Now are we going to stop here? No. We are asked to find what? X. That is the resultant displacement and not the square of x. How do you make x stand alone from here? Like I've taught, whenever it's carrying square, you take the square root of what? Both sides. Square root of both sides. This square will cancel this square root sign. So x will be left here. X will be equal to the root of 129. And x finally will now be equal to, let's see what root 129 is. Root of 129 is 11.36. And because the unit for distance or displacement they were making use was kilometer, I will add kilometer. And this is the magnitude of its displacement. This is the magnitude of its displacement. So I hope you clearly understand how these very questions on the board were solved. So back now, we'll be getting to question number 9. So here is question 9. It reads, a stream is flowing at 0.75 meter per second and a boat heading perpendicular for the stream landed at an angle of 30 degrees. Now what is the question? Calculate the velocity of the boat. So we take solution. Now we need a diagram for this question to properly understand what it's saying. It said a stream is flowing at what? 0.75 meter. So assuming this was the spring or the stream, wherever, they said it was flowing. So let's assume this is the direction of flow of the stream. They said at 0.75 meter per second. Now what is next they say? They said a boat heading perpendicular for the stream landed at an angle of 30 degrees. Now, the boat initially wanted to go in this direction, perpendicularly. Okay? But because of the pull of the flow of the spring, it ended up moving somewhere around there at 30 degrees. That is what the question states. So this is now the direction of the boat. Okay? So we know that this is direction of the stream and this is direction of the boat. Now, do we know the velocity with which the stream is moving? Yes, they said it's 0.75 meter per second. So I will say meter per second. Now, what's the question? Calculate the velocity of the boat. The velocity of the boat is this. Now we know the direction of the boat will be this, but do we know the value of the velocity? No. So we call it x. Now we can bring this out. Let's cover this. Let's complete the triangle. We can bring this out and we say something like this and like this. Then we call here 30 degree. And then they said this direction for the boat is 0.75 meter per second. This direction for the boat itself is x, while for the stream is 0.75. Now, how do we now get x? That is the velocity of the boat. Now, what comes to mind when you see this type of question? You have two sides and an angle. What comes to mind is what? Trigonometry. So we're using one of the trigonometry here to find how to get our x. Now, one of the trigonometric ratio we know. We have sine, we have cos, and then we have tan. Sine, cosine, and tangent. Now, which are we going to use for this very question? It will be determined by which side was given. Now, this longest side is called hypotenuse. The longest side is called hypotenuse. X is hypotenuse. Now, this side that is lying with the angle is the adjacent. So you have hypotenuse and you have adjacent. Which of the trigonometric ratio makes use of these two? The answer is what? Cosine. So we say cos. What is the angle given? 30 degree. So cos 30 degree is equals to adjacent, okay, over hypotenuse. Now ask yourself, what is our adjacent and what is our hypotenuse? So from here we say cos 30 degree is equals to, what's our adjacent? Our adjacent is 0.75. So 0.75 over what is our hypotenuse? Our hypotenuse is what? X. The longest side is x. So from here what will happen? We draw the line. From here we now have cos 30 degree equals 0.75 over x. What's the value of cos 30? Cos of 30 degree is 0.866. Okay? That is what we have as our cos 30. Now what do we now write? We now equals to 0.75 over x. Now this is what we now have. Now what are we looking for? We are looking for x. So we have to make x subject by cross multiplying. What would that give us? 0.866 times x is equals to 0.75. 0.75. So from here what will now happen? We are trying to get a value for x. So to make x stand alone, divide both sides by what is attached to it. And what is attached to x here? You have 0.866 over 0.866. Divide both sides by 0.866. Now this we cancel this. What is left here? You have just x. X is equals to what? 0.75 over 0.866. Okay? Now from here, what are we going to have here? That's what we get. 0.75 divided by 0.866. Now our final answer is approximately 0.87. So the velocity with which the boat will move in this direction is 0.87. And what is the unit for velocity? Meter per second. So this is the answer to this very question. So we're going to the last question on this side. Solution. We read, then we solve. Now the question reads, if a load of mass 10 kg, M was given to be what? 10 kg. They said, stretches a cord by, emphasis on the by. Now if you have studied my video on elasticity, I explained something there. Whenever you see stretches by, or you see extend by, or you see compress by, the value that follow after it will be for the what? Extension. So E, extension in this case, is 1.2 cm. Now mind you, we don't make use of cm in our calculation. So let's convert from cm to what? Meter. How do you do that? Divide whatever is the value by 100. So let's divide 1.2 by 100. What do we get? We have 0.012 in meter. So this is what we now have. So let's continue reading. They said, what is the total work done? So work done in this case is what? Unknown. Our work done is unknown. Now we like to what? Illustrate this question. I would like to show you the diagram. We were told that, okay, let's say this is the rope, okay, and this is the cord, and this is the mass that was attached. Let's say a box. It has a mass of what? 10 kg. Now, we know from our knowledge of gravitation that whenever there is a mass, there will always be a weight. Now, the weight of the body is due to the force of gravity that is acting on the mass. I hope that is clear. So, this mass has a downward force called weight. Okay? And this weight will act on the cord to stretch it. Is it not? So, the weight of the body, the weight of the mass, is equals to the force that is pulling on the cord. Is it not? The force that is stretching the cord. So whatever we get as the value for our weight is the same as the value for the force acting on this. So how do we now get this? How do we get our weight in the first place? We know that weight is equals to mg. Is it not? Now ask yourself this very question. How do we get our weight now from here? Do we have our mass? Our mass was given to be 10 kg. And gravity, like we know, is what? 10, approximately 10. So 10 times 10. What does that give us? 100. Now, what should be the unit? We know that weight is a form of force. So the unit for weight should also be what? Newton. Now we have our value for weight. Now we've gotten our value for weight. Remember the relationship we drew here. Our weight is equal to the force acting on this cord. So weight is equal to force. So therefore, force is equal to what? 100 Newton. So watch out, guys. From this question now, we now know what our force is. We now know what our mass, our extension is. So what are we finding? Work done. Now because this question was brought from elasticity, there are different formulas for finding work done in a spring or an elastic string. And one of the formula that we can use here, because of the parameters we have, is work done, okay, is equals to 1/2 force times extension. This is the formula we can use here because of what we have. Now this work done will now be equals to 1/2. What do we get as our force? 100 Newton. Now what was given as our extension? 1.2 cm. But do we work with that? No. We work with the equivalent in meter. Now what is that? We have 0.012. So guys, this is what we have, okay, in meter. So let's do this now. We now have 1/2 times 100 times 0.012. That gives us 1.2. Okay? So what do we now have? Work done will now be equal to what? 1/2, okay, times 1.2. That gives us 0.6 joule. Why joule? Because joule is the standard unit for what? Work done. So guys, you are free to go through it and see how everything was solved. So about now, we've come to the end of Physics Calculation Series 2. Don't forget to share this video with your friends. I will see you guys in the next series.